So in this question, we've got a circle with centre x is 3, y is 1. And the tangent, which is this line here, the tangent line, hits the circle at point A, which is x is 8, y is 3, at 8, 3. Now our goal is to find the area of triangle OAB, where O is the origin. This point C here, that's the centre of the circle. So how are we going to go about finding that? Well, first of all, our goal with triangle OAB, that's what we're trying to find, something like this. So that's O, that's B, that's A. We need to find, first of all, the point B. We need to find this line here, the line L, which will help us find point B. And from that, we can then split that into two parts and then go a straight line down there, and then we can work out the area of this triangle, area of this triangle. So area of a triangle, we just need area equals half of the base times the height. So that'd be pretty straightforward. Now, this triangle, first bit here from A, where it comes straight down, that is something we can do right from the start. So if x is 8, and here we've got the origin, then this length of the base here is going to be 8. And also from the origin, if y is 3, we know the height is 3. So this triangle here, we call that triangle 1. So triangle 1 is half times 8 times 3, which will give me 12. So that's my first part done already. We now need to do the complicated bit, which is this bit. So before I can start anything on that, I probably need to find this tangent line equation first of all. But I don't know anything about it other than it's the point 83. So I don't know the gradients or anything. But I've got this one here because this is the tangent line to the radius of the circle at point A. I can find the gradient of that, and I know a point and this point, so I can find the gradient of that and find the negative reciprocal to find that one. So let's do that. So let's find the gradient of this line here. So radius, gradient. So for that, m equals the change in y over the change in x. So what have we got here? So change in y and change in x going from here to here. So I've got change in y goes from 3 to 1. And my x goes from 8 to 3. So 3 minus 1 is 2, 8 minus 3 is 5. So my gradient of the radius is 2/5. So now from that, I can find the gradient of my tangent line. So my tangent gradient, as that line there is a tangent, it will be perpendicular to the radius. So therefore, I can do the perpendicular bisector gradient formula, minus 1 over m, which equals minus 1 over 2/5, which will give me minus 5 over 2. So therefore, my m of my tangent line, I call that mt, is minus 5 over 2. Okay, now if I know the gradient and I know an x coordinate and a y coordinate, I can find the equation of that line. So then if I use y equals mx plus c, now my building blocks for this, I've got my y is 3, my m for this one, I'm going to use that gradient there, so mt in this case, so minus 5 over 2 times x, well here my x is 8, and then plus c. So now from there I can solve for c and I can complete my equation for the tangent line. So now 3 equals minus 5 times 8 over 2. Well, 8 over 2 is 4. Minus 5 times 4 is minus 20. And then add c. So from that, add 20 to both sides. I get 23 equals c. So therefore, this equation of the tangent line would be y equals minus 5 over 2x plus 23. Okay, Now with that, I could find the point B. Now, the quality I've got here at point B is that it sits on the x-axis. Now I need to find out what point on the x-axis that is, but I know on that axis y is 0. So if I plug in 0 here, I can then solve for x. So 0 equals minus 5 over 2x plus 23. Subtract 23 from both sides. So I've now got minus 23 equals minus 5 over 2x, times both sides by 2. So now I've got minus 46 equals minus 5x. And now divide both sides by minus 5. So if I divide that by minus 5, divide that by minus 5, I'll get x equals 46 over 5. So here I've got x equals 46 over 5. And my y coordinate will be 0. So that's my point there from solving this equation. So 46 over 5 is this point here. So 46 over 5. Now I know this point here is 8. So if that point there is 46 over 5, I know that this length is going to be 6 over 5. Okay. So now that's the final part of my building blocks to find my answer. So if I do triangle 2 is base times height times a half. Half times 6 over 5 times 3. Okay. 6 3s are 18 and 5 2s are 10. So that gives me 18 over 10, which is 9 over 5. But now my total area is going to be T1 plus T2. So total area, that's my area, equals T1 plus T2, which is 12 plus 9 over 5, which will give me 13.8. So therefore the area of triangle OAB is 13.8, and that be my answer, and that's my technique to find that area of that triangle OAB. Okay.